Okay, so today we're going to talk about the rational root theorem. Now, the rational root theorem is one way that we can find a lot of different roots from very large polynomials that might be a bit too big for us to factor. So in this one, we've got this 6x to the power of 4 plus 29x to the power of 3 plus 40x squared plus 7x minus 12. Factoring that ourselves might be tricky. However, with this theorem, we can find some factors that could work and then test them out. So first, step one, you got to determine the factors of the constant and the factors of the leading coefficient. So the constant number is the number right there at the end. It's the number that is not, it does not have a variable with it. It's just your constant term. Next thing we're going to need to find is the leading coefficient. Okay, your leading coefficient is the number right in front of your variable that has the highest degree. So in this case, the leading coefficient is 6. Now what we're then going to do, so down here we listed what those were. The leading coefficient was 6. The constant term was 12. Then we want to list the factor of those. So the factors of 12, the numbers that I can multiply to get 12, would be 1, 2, 3, 4, 6, and 12. The numbers that will multiply to give me 6 would be 1, 2, 3, 6. Okay, so that's step one, just listing the factors of your constant and the factors of your leading coefficient. Step two, we're going to find all possible roots by dividing the factors of the constant term by the factors of the leading coefficient. So notice what they put right there. Down here on the bottom, we've got our leading coefficient. Up on the top of that fraction, we got the constant terms. So what we're going to do is take all of the constant term numbers up here and put them over each of the leading coefficient terms down here. So if I started with 1, I would have 1 divided by 1, okay, which would give me 1, and we make it plus or minus. Then I could have 2 over 1. Okay, that's where that 2 came from. 3 over 1. We got the 3. 4 over the 1. 4. 6 over the 1. That's where we got the 6. 12 over the 1. 12. So now that I've done all of these top ones over 1, now we'll do them all over 2. So now 1 over 2 gives us that 1/2 that we see right there. Okay, then 2 over 2, we already had a 1, so that's in there. 3 over 2, we have a 3/2. 4 over 2, we've got a 2. 6 over 2, we've got a 3. 12 over 2, we've got a 6. So now we do all these numbers over the 3. 1 over 3 becomes a 1/3. 2 over the 3 becomes a 2/3. 3 over the 3 is a 1. 4 over the 3, 4/3. 6 over the 3 should be 2. 12 over the 3, 4. And this just repeats. You take every single number from your constant terms, divide it by every single one of the numbers in the leading coefficient, and it leads to this huge list of possible roots. Now, not all of them are roots. This one was an x to the power of 4, meaning there's a total of 4 roots. However, we've got way more numbers than just 4. So in order to test out which one actually works, the next step, step 3, says to substitute each possible root in the polynomial until you find one that causes the polynomial to equal 0. This one is the rational root. So we're going to test -3/2. Now notice the similarity between what we have right down here and our equation up at the top. Okay, we had 6x to the power of 4, and now I've got 6 times -3/2 to the power of 4, plus 29, -3/2 to the power of 3, plus 40, -3/2 squared, plus 7, -3/2, minus 12. Now, when we evaluate that entire thing, we get 0. Whenever you plug in any of these numbers, any of the numbers we found in step 2, into the original equation and you get a 0, that means you just found a root. Negative 3/2 is one of our rational roots. What we would do after that is we're going to factor this polynomial by using synthetic division and using the first rational root as the divisor. Okay, so in this particular example, our rational root that we found was negative 3/2, and so I would then use synthetic division on our original equation, 6, 29, 47, negative 12, negative 3/2, so negative 18 divided by 2, negative 9. Oops, sorry, I should have just brought that down. Okay, and then, so that'll be negative 9, which will give us a 20. And then negative 60 divided by 2 should become negative 30. Okay. Negative 15. So that'll then be a negative 8. And then we'll get positive 12, 0. So what this tells me at that end, once I've divided this through, is that our original equation, 6x to the power 4 plus 29x cubed plus 40x squared plus 7x minus 12, if I take all of that and then divide it by x plus 3/2, what that gives me is 6x cubed plus 20x squared plus 10x minus 8. This also tells me something. It tells me that my original equation can be simplified into an x plus 3/2 times by 6x cubed plus 20x squared plus 10x minus 8. So this whole equation factors into that. Now, negative 3/2 is not the only, it's not the only root. So we could continue pulling out more roots and using synthetic division to break it down. Next, we'd move on to step 5. Step 5, if the dividend is a second degree polynomial, factor to find any additional roots. Our dividend, this number right here, the number we got out of the synthetic division, it is not a second degree. It's a third degree, so it's still too big. I would continue using the rational root theorem to pull out more. Okay, if the dividend does not factor, there would be no additional roots. If the dividend is greater than second degree, this is what I was saying, then we simply repeat the steps 1 through 4 until it is a second degree. So we continue testing more of our possible rational roots with this and using synthetic division to divide them out. Okay, so now let's see what that looks like on a problem. First thing we're going to do is find all the possible rational roots of our function f of x up here. Okay, so first we've got the constant. Okay, so we got to find the constant. Now, our constant was negative 11. Okay, so the factors of 11 would be 1 and 11. Okay, next we got coefficients. Okay, the coefficient, because we don't see a number in front of x, that means it's just 1. Alright, so now we find all the possible roots that can come out of that. So 1 over 1, positive or negative 1 could be a possible solution, and 11 over 1, so positive or negative 11. So now we want to test to see which one of these actually work. What I am going to use is my calculator to help make this a little bit easier. Okay, so first thing to do is type in the equation as it was originally. Okay, so we're going to have x to the power of 3. Okay, use this caret sign right there. That's the one to use in order to do a power. So to the power of 3 minus 13x plus 23 minus 11. Okay, alright, so now that we've got that in, I'm just going to press enter. Now right now this number is gibberish. We need to do one more thing. We need to tell the calculator what x is going to be. So first number I want to test is a positive 1. So let's put in a 1. And now down here you'll notice this STO button. That's for store. We're going to put 1 into x. So now the calculator believes x to be a 1. So press second enter. Showed that again. Press second enter again. Notice it gave me the equation that I had just typed up earlier. Need to make sure I fix that. And now I can just press enter. And lo and behold, we got a 0. That means that 1 does give us a 0. Now, if you don't have a nice calculator like this at home, it's fine. You can still just replace x with a 1 to do this testing. 1 to the power of 3 minus 13 times 1 to the power of 2 plus 23 times 1 minus 11. And notice, it still gives us that same answer. Okay, so alright, so now that we know that 1 is one of our solutions, what we are going to do is take our equation up here and we are going to divide it. So the x cubed minus 13x, that should be squared. Sorry, if your paper has that mistake, make sure to fix it. This should be squared plus 23x minus 11. We are taking that whole thing and we are going to divide it by x minus 1. Because we figured out that a positive 1 was a root. So this is the factor that has 1 as a 0. Okay? So, using this one, we'll put that one in red. So we've got 1 and we're using all these from right here, which were these same ones above. So 1, negative 13, 23, and minus 11. So now that we've got those, now we can begin bringing those down and doing this division. So bring down the 1. 1 times 1 is just 1. Okay, and then negative 13, that becomes negative 12. So 1 times negative 12 becomes a negative 12. 23 minus 12 becomes 11. And then 1 times 11 is just 11. 11 minus 11 becomes 0. So this right here becomes a new equation as well. This one becomes x. So because it was x cubed up here, this one down here must be x squared minus 12x plus 11. And let's not forget about the x minus 1 factor that brought us here. Okay, so now we've begun simplifying this. I think we can still take it further. However, we are down to a power of 2, so you could proceed in two ways. You could use factoring by grouping to kind of finish up this factorization, or if you know any other methods for factoring quadratics, that's fine. You can use those and finish up this problem to find the remaining roots. Or we could continue by testing some more. So that's actually what I'm going to do. I'm going to put in a negative 1 into x so that we can test to see whether or not that would work in our equation. And I just need to make sure I've got it. So yeah, x cubed minus 13x squared plus 23x minus 11. So I've typed that all in. Negative 1 does not work. It did not give us a 0. So now let's go ahead and test maybe negative 11. We'll store it into x. Second enter, second enter. Got our equation back. Test it. Negative 11 did not work. So now let's try 11. Store it into x. Second enter, second enter. We've got our equation again. So that one does work. 11 does work. So now we've got this new factor to try. And we're going to do that. So now let's use this. So we're going to divide out an 11. We're going to take the x squared minus 12x plus 11, and we are now going to divide that one by x. Oops, let's switch that. So that's going to be x minus 11. Okay, so that's going to look like in our synthetic division, we've got the 11 over there. And then I've got my purple on the inside. And I'm just taking the term that I just found from the previous one. Okay, and we're going to simplify this one further. So we're going to bring that one down, and that becomes 1. 11 times 1 is 11. So now 12 minus, or negative 12 plus 11 is negative 1. 11 times negative 1 is then going to give us negative 11. And then we've got 0. Okay, so now we've got our other factors that we've already figured out from before, from up here, we know that we had the x minus 1. That was up there. Then we factored it into we took this purple and we further factored it. We took out that 11, and so that becomes our other factor, x minus 11. And when we factored out that negative 11, we got this right here in orange, the x minus 1. There we go. We just found all of the factors, testing it in the calculator, and using synthetic division. This brings us to our final answer, in which we list all of our factors. Notice, the 1, this x minus 1, which is a 0 of just a positive 1, that's when those equal 0, happened twice, so I write it as 1 with a multiplicity of 2, and then an 11. And that is all of the zeros. So that's what you guys are going to be doing today. I've left you with an answer key for all the odd problems in Canvas. Make sure to use it.